There are 7 questions in total and time allotted is 4 minutes and 30 seconds. 3 questions are numerical answer type questions and 4 questions are multiple choice question with only single correct option. Let's begin. Time is up. Under low-level injection assumption, the injected magnetic carrier current for an extrinsic semiconductor is essentially diffusion current. The primary reason for the widespread use of silicon in semiconductor device technology is the abundance of silicon on the surface of the earth. A semiconductor is irradiated with light such that carriers are uniformly generated throughout its volume. The semiconductor is N-type with doping concentration 10 raised to the power 19 per centimeter cube. If the excess electron concentration in the steady state is 10 raised to the power 15 per centimeter cube, and if minority carrier lifetime is equal to 10 microsecond, then the generation rate due to irradiation is, you know, that recombination rate is equal to excess hole concentration divided by minority carrier lifetime. But it is also provided that the semiconductor is in steady state. Therefore, generation rate will be equal to recombination rate. So, generation rate will come out 10 raised to the power 15, which is nothing but the excess electron concentration divided by 10 microsecond, which is the minority carrier lifetime. Then we will get so the first option is correct. In a p-type silicon sample, the hole concentration is 2.25 into 10 raised to the power 15 per centimeter cube. Let me write it first. And the intrinsic carrier concentration is 1.5 into 10 raised to the power 10 per centimeter cube. Then the electron concentration is, from the mass action law, we know that the square of intrinsic carrier concentration is equal to hole concentration multiplied by free electron concentration, which will give the free electron concentration to be equal to square of intrinsic carrier concentration divided by hole concentration. After calculating the expression, you will find the value of free electron concentration to be equal to 10 to the power 5 per centimeter cube. We will see the seventh question first. It says a bar of gallium arsenide is doped with silicon such that the silicon atoms occupy the gallium and arsenic sites in the crystal. Which one of the following statement is true? Silicon atoms act as p-type dopants in arsenic sites and n-type dopants in gallium sites. It is true because silicon is group 14th element and arsenic is group 15 element and gallium is group 13 element. If silicon is doped with gallium, then it will act as n-type dopant for gallium as there are more number of electrons in its valence band. Similarly, if silicon is doped with arsenic, then it will act as p-type dopant as it has lower number of valence electrons in its valence band. Now the fifth question is, a small concentration of minority carriers is injected into a homogeneous semiconductor crystal at one point. An electric field of 10 volt per centimeter is applied across the crystal and this moves the minority carrier's distance of 1 centimeter in 20 microseconds. First we will find the drift velocity, which is equal to distance covered by the charge carriers divided by the time taken, which will give 5 multiplied by 10 raised to the power 4 centimeter per second. And we also know that drift velocity is equal to mobility into electric field. Therefore, mobility is equal to drift velocity divided by electric field, which will give us the value of mobility to be equal to 5000 centimeter square per volt second. Now, for the sixth question, at 300 Kelvin, the whole mobility of semiconductor is 500 centimeter square per volt second, and it is provided that thermal voltage, which is kT by Q, is equal to 26 millivolt. The whole diffusion constant is, we know that from Einstein relation we have diffusion constant divided by mobility equal to kT by Q. Therefore, diffusion constant is equal to 500 centimeter square per volt second multiplied by 26 millivolt, which will give the value of diffusion constant to be equal to 13 centimeter square per second. So the answer of the fifth question is 5000 and the answer of the sixth question is 13.